Tsunami. You may have heard of tsunamis, the enormous waves that crash into the coastline and flood entire towns, even cities. The 2011 Tohoku tsunami, which slammed into Japan, caused billions of dollars worth of damage. Thousands of lives were lost. It even caused the meltdown of the Fukushima Daiichi nuclear power plant. But what exactly causes such waves to form in the first place? The waves produced during the Tohoku tsunami were quite simply huge. The tallest may have reached a height of 133 feet, scientists believe. In certain areas, these waves traveled as far as 6 miles inland, wiping out nearly everything in their path. Waves of this size are usually caused by earthquakes. In the case of Tohoku, the earthquake was classified as an undersea megathrust earthquake, and it is considered the biggest earthquake to ever have hit Japan. In fact, it was the fifth largest earthquake ever measured since humans began tracking the size of earthquakes in 1900. The earthquake caused the ocean floor to be thrust upwards by as much as 15 feet. When the seabed rises, so does the ocean above it, and the more shallow the water is where the earthquake occurs, the larger the tsunami will be. Unfortunately for the inhabitants of Japan's coastline, the earthquake happened just 45 miles off the coast. Tsunamis behave differently than average ocean waves. For one thing, the type of waves you see at the beach are caused by wind. They tend to have a wavelength, that is, the distance between crests of two consecutive waves of around 330 feet. They also tend to average about 6.6 feet in height. By contrast, deep ocean tsunamis typically have a wavelength of 120 miles. The amplitude of the waves or the distance from the top of the wave to the bottom is usually 3.3 feet. This isn't a very big wave at all. However, as a tsunami gets closer to shore, it grows dramatically in size. This is because the sloping of the coastline causes the wave to be compressed. While its speed and wavelength decreases, its amplitude increases. In turn, the frequency of the waves, or the number of wave cycles per second, also increases. One indication that a tsunami is on its way is that the water that normally covers the shorelines begins to recede. Some of those who were unlucky enough to experience Tohoku tsunami describe the ocean receding out to sea before coming back in the form of some very big waves. Not all tsunamis are formed by undersea earthquakes. They can be triggered by explosions and underwater landslides. Picture a glacier cracking in half and sending a chunk of ice miles long plunging into the ocean. That will cause a gigantic amount of water to be displaced and can often result in a tsunami. Similarly, a tsunami could be generated by a giant meteor splashing into the ocean from outer space, or a volcanic eruption in an underwater volcano, and yet the most common causes of tsunami remain underwater earthquakes. The reason we don't hear about too many tsunamis striking the Atlantic Ocean coastlines of the US and Europe is that they more frequently happen in the Pacific. The floor of the Pacific Ocean consists of oceanic plates and continental plates that constantly slide against one another. On occasion, the plates get stuck, causing the upper plates to snap upward several inches or even a few feet, pushing a whole section of the ocean up with it. Again, a rise of few inches may not sound like much, but it can cause devastating waves. To achieve equilibrium, the water above the crack in the plates spreads out. It starts moving towards the shore very quickly, often at hundreds of miles per hour. And when it starts to reach shallow land, that's when it transforms into what we think of when we see tsunamis. Terrible disasters often result. By definition, all waves transmit energy from one place to another. The energy of an underwater earthquake, in other words, is often transmitted to land in the form of a series of tsunamis. Like the surfers who ride them, waves carry energy forward. Number 6. Read the paragraph. The reason we don't hear about too many tsunamis striking the Atlantic Ocean coastlines of the US and Europe is that they more frequently happen in the Pacific. The floor of the Pacific Ocean consists of oceanic plates and continental plates that constantly slide against one another. On occasion, the plates get stuck, causing the upper plates to snap upward several inches or even a few feet, pushing a whole section of the ocean up with it. Which sentence best summarizes the paragraph? A. Tsunamis mainly occur in the Pacific Ocean. B. Earthquakes are the primary cause of tsunamis. C. The movement of plates pushes ocean water up, causing tsunamis. D. It is safe to live in the US and Europe than in the Pacific. Number 7. How large were the waves during the Tohoku tsunami? A. 3.3 feet. B. 15 feet. C. 133 feet. D. 330 feet. Number 8. Read the sentence. In certain areas, these waves traveled as far as 6 miles inland, wiping out nearly everything in their path. What does the author tell the reader with the use of the phrase, wiping out nearly everything in their path? A. Tsunami waves travel very far inland. B. Tsunami waves wash things out. C. Tsunami waves are very powerful. D. Tsunami waves destroy everything they hit. Number 9. Choose 2 sentences from the passage that best support the conclusion that tsunamis are caused by earthquakes. A. In fact, it was the 5th largest earthquake ever measured since humans began tracking the size of earthquakes in 1900s. B. When the seabed rises, so does the ocean above it. C. One indication that a tsunami is on its way is that the water that normally covers the shorelines begins to recede. D. But it can cause devastating waves. E. The energy of an underwater earthquake, in other words, is often transmitted to land in the form of a series of tsunamis. Number 10. Summarize how a tsunami occurs.